Hi guys, in today's lesson, we are going to be looking at introduction to redox equations and reactions. In our previous lesson, we worked extensively on non-redox reactions and equations. We balanced various non-redox equations. Today, we are not going to be balancing redox equations, but we're going to be looking at various chemical situations that bring about redox equations. So you had various situations. So when we talk about redox, reaction or equation, the word redox is reduction, oxidation. So when we talk about redox reaction or redox equation, we are talking about two things happening at the same time. As there's a reduction in one side, there's also an oxidation going on the other end. So when we have, what we call redox, these are the situations that bring about reduction, oxidation reaction. So first of all, the addition the addition of oxygen, the addition of oxygen to a given, element, atom of element, the addition of oxygen and the removal of hydrogen, the addition of oxygen and the removal of hydrogen is oxidation. So now look at this is vice versa. Let me put this way. Now, the first situation that brings about redox, as reduction oxidation, is simply this. Whenever there's an addition of oxygen to a given element, addition of oxygen and the removal of hydrogen also, these two things take place simultaneously, sometimes. So whenever you have oxygen added to a given element, atom of element, we call that oxidation. While whenever we have removal of hydrogen from a given compound, we also call it oxidation. That means if the opposite takes place, that means if oxygen is being removed from a given compound, it means we have what we call reduction. While when hydrogen is added to a given compound, we have what we call reduction also. So let's look at, we have an example like this. Don't forget the addition of oxygen and the removal of hydrogen is what we call oxidation, while the removal of oxygen and the addition of hydrogen is what we call reduction. So let's look at this. Let's say we have calcium, which is a solid, plus oxygen, which is a gas. When they both combine together, we have calcium oxide, which is another solid. Now we're going to balance this very equation first. Calcium plus oxygen is equal to calcium oxide. So what do we have? You're going to add to these two atoms of oxygen. In our previous lesson, we worked on how to balance non-redox reaction. So these two atoms of oxygen react to this place. That becomes 2. Calcium also reacted to this place to make the calcium become 2. So what do we observe here? When you look at this very calcium, there's a reactant, there's a product. But like on the reactant end, we have just ordinary calcium. After the calcium combines with oxygen, we end up with calcium oxide. So what do you observe here? You find out that the calcium here on the reactant, on the product end, has oxygen added to it. So it means we have an oxidation. Whenever oxygen is added to a given atom of an element or even to a given compound, we call it oxidation. So this very calcium became oxidized. While when you look at the oxygen here, we have two atoms of oxygen. While on the product end, the number of oxygen reduced from 2 atoms to 1 atom of oxygen. So oxygen here experiences a form of reduction. There's a reduction in oxygen quantity. So don't forget, when we talk about redox, we are talking about two things happening at the same time, reduction and oxidation. So for calcium became oxidized on the product end, while oxygen became reduced on the product end. 2 atoms of oxygen became 1 atom of oxygen here, while calcium that had no oxygen picked up 1 atom of oxygen on the product end. So this is a very good example of a situation that brings about redox, reaction. So don't forget, whatever undergoes oxidation is what we call a reducing agent. So this is a reducing agent because it's underwent reduction. It underwent oxidation, I beg your pardon. Why oxygen here that underwent reduction is an oxidizing agent. This is an oxidizing agent. So whatever goes through oxidation is a reducing agent, and whatever goes through reduction is an oxidizing agent. So there's the first situation that brings about redox reaction. So let's look at the next. The next situation we have is addition. The addition of electronegative The addition of electronegative elements, is oxidation. When you add electronegative elements to a given atom or to a given compound, we call that situation oxidation. So that means when you remove electronegative elements, we call that reduction. Or when you add electropositive element to a given compound, is the opposite of this. We also call that reduction. But when you add electronegative elements, such as chlorine, such as oxygen, we talk about electronegative elements that take in electrons. When you add them to different elements, other elements, or to different compounds, we have what we call oxidation. So let's have a given chemical reaction here to explain this. So when we have sodium, for example, which is a solid, but plus HCl, which is aqueous, then we have sodium chloride, let's say aqueous sodium chloride, then plus hydrogen gas. Now look at the situation here. When you have sodium plus hydrochloric acid, this conc hydrochloric acid, we end up having sodium chloride, which is aqueous, plus hydrogen gas being given off. So let's try to balance this equation first. We have two atoms of hydrogen here on the product end. Just one here. We add it to this place. That is two hydrogen. Chlorine now is two. Add it to this place to make it become two chlorine. We did this in our previous lesson, so I'm very sure you understand what I'm talking about. The sodium here on the product end is two. We add it to this place. That makes the sodium 2 also. So let's see if this, very, what I call a law, if this is very correct. Don't forget, when electronegative elements are added, when we add electronegative elements to various elements of various compounds, we end up having what we call oxidation. That means when we remove electronegative element also, we also have what we call reduction. So this sodium here on the reactant gave us sodium chloride. So chlorine here has been added to sodium on the product end. So that means sodium passed through what we call oxidation. Sodium became oxidized. Automatically, sodium is a reducing agent, ROA. It's a reducing agent. And when you look at hydrogen chloride, that's HCl. The HCl here, as you can see, there was chlorine here on the product on the reactant end, while on the product end, the chlorine became lost. You have no chlorine, as you can see, no chlorine here on the product end. So chlorine, which is electronegative, was removed from the hydrogen here in this very compound for us to be left with just hydrogen gas. So for the fact that this electronegative element chlorine was removed, it means this is reduction. So HCl here underwent reduction. This is reduction scenario. So it means HCl is an oxidizing agent, OA. This is an oxidizing agent. So don't forget, when you add electronegative elements, is oxidation. When you remove electronegative elements, is reduction. That means when you also add electropositive elements, we call it reduction. When you remove electropositive elements, we call it oxidation. So quickly, let's look at the third point. So here's the third point. The third point is simply this: increase in oxidation number, increase in oxidation number is oxidation. Increase in oxidation number is oxidation. So vice versa. So when there's an increase in oxidation number, we call it oxidation. But whenever we have a reduction in oxidation number, we call it reduction. As simple as that. So whatever we have here, if you flip it, if you experience the opposite, then you're going to get a reduction. So if there's an increment in oxidation number of a given, reactant, atom of element, we call it oxidation. While if there's a reduction in the oxidation number of any given, reactant element, we call it reduction. So let's have a look at this. Let's look at this. So we have hydrogen gas, for example, plus chlorine gas. We look at hydrogen gas plus chlorine gas, we end up with HCl gas. It's another gas also. This chlorine is a gas. This. So when you look at this, hydrogen is a gas, chlorine is a gas, then HCl is a gas. So when you look at this scenario, increment in oxidation number is oxidation, reduction in oxidation number is reduction. So let's see what is an oxidation number of hydrogen gas here. Hydrogen gas here, without having any reaction with any other, atom of element, you can assume that this hydrogen has an oxidation number of 0. Chlorine also has an oxidation number of 0. So by the time they combine together, we end up having HCl. So what's the oxidation number of hydrogen here on the product end? First of all, we can even balance. We have not even balanced that. This 2 here, we add to this, to 2 chlorine. So this is balanced already. So let's carry on. Hydrogen here, we have oxidation number of just +1. Chlorine here, we have oxidation number of -1. So when you look at this hydrogen here, the fact is this: whenever we talk about an atom of an element that has not yet reacted with any other external atom of element, we assume that that very atom of element is a virgin atom of element. That is, its oxidation number is 0. So after this reacted with this, we got this, and hydrogen became +1. So there's an increment in oxidation number. So there's an oxidation on this end. Hydrogen became oxidized after reacting with chlorine. So when you look at chlorine, chlorine is 0. Chlorine moved from 0 to -1. That means chlorine lost 1 electron. Oxidation number reduced from 0 to -1. It means there is a reduction. So if there's a reduction, don't forget oxidation number here is 0, oxidation number here -1. Oxidation number here is 0, oxidation number here +1. So it means hydrogen is a reducing agent. Whatever undergoes oxidation is a reducing agent. Whatever undergoes reduction is an oxidizing agent. Okay, here's the final point. Now the fourth point is this. Now, the loss of electron, by a given atom of an element, the loss of electron is called oxidation. When an electron is lost, we call it oxidation, while the gain of electron is reduction. Now don't forget, and that's how we call this. That's how we call this redox, reduction oxidation. As one place or as one end of the reaction loses electron, the other end gains the very electron. So when electron has been lost, there's a fourth and the final point, the fourth and the final situation that brings about redox reaction. So as electron is being lost by a given atom of element, either on the reactant or on the product end, you call that situation oxidation. While on the other end, electron that has been lost is being gained or is being taken in. So let's look at this very situation. I'm going to be using this very equation from the third, explanation, the third scenario. HC as H2 plus chlorine, hydrogen gas plus chlorine gas will give us hydrogen chloride, which is also a gas. So let's see what happened. Now, don't forget oxidation number here 0. Oxidation number here is 0 also. Oxidation number on the product end is +1, while here is -1. Now, what really happened? How do we explain the situation? How did this move from 0 to +1? How did this move from 0 to +1? So let's look at what happened. There's an increment in oxidation number for this, but this increment has a link with a loss of electron. So let's say one atom of hydrogen, this hydrogen here, just one atom of hydrogen gas. Naturally, one atom of hydrogen gas will give out 1 electron to become electropositive. This is just plus. So in a situation whereby we have 2 atoms, that's a molecule, that means we're going to have just 2 electrons also being given off. Balance this with 2. This is what we have. So the fact is, when a given atom of an element loses an electron, it becomes electropositive. While when the opposite takes place, it becomes electronegative. So let's also look at the chlorine. The chlorine, as you can see, chlorine here, oxidation number of 0, became -1 after the reaction was completed. So chlorine here from 0 became -1. So how do we explain this? Now this is how we're going to explain it. Naturally, one atom of chlorine, which is a gas also, we take in an electron. Don't forget chlorine on the periodic table, number 17, 17th element. So when you look at oxidation number, you're going to end up having, you find out that chlorine needs 1 electron. So naturally, chlorine as a gas needs 1 electron. That's this to become electropositive. To become electronegative, I beg your pardon. To become this. So the fact is, from 0 to plus, this electron naturally is -1. -1, 0 plus -1. You give us 0 minus 1, which is -1. Unlike this, that is 0 minus electron is -1. That will give us 0 plus 2, which is plus 2. So 2 times the plus 1. So what do we have? So that's it. So chlorine naturally plus 1 electron makes it becomes electronegative. So the fact is this, whenever an atom of an element gives out an electron, it becomes electropositive. That means oxidation has taken place. So when you look at this, this this gave out 1 electron, became this. So there's an oxidation on this end. Naturally, hydrogen is a reducing agent. This underwent oxidation, O, while this very one passed through reduction from 0 to -1, this reduction. So why did it reduce? Because it took in one what? Electron. So this is an oxidizing agent. As simple as that. So these are all the situations that bring about reduction oxidation reaction. So we are done with this introduction at this very point. So in our next set of lessons, we're going to be balancing the various redox chemical equations. So we've seen what bring about the various redox reactions. In the next set of lessons, you're going to be balancing various redox equations. So we're done with today's lesson. At this very point, if you gain one or two things, I would love you to give me a follow at Revelation over Facebook and subscribe to the very channel at Edge Mosaic. And please share this lesson also with others. See you in the next lesson. Thanks and bye for now.